record this meeting. And we're talking about continuity today. So f of c is defined, so you can actually find the value at c. You can find the limit at c for both left and right, and that the limit equals f of c. So let's go ahead and try this. So question 1. So I'll give you a couple seconds, and you guys are going to tell me, is this continuous or is this not continuous? X cubed plus 7x. Is it continuous or not? Well, let's think about the parent function right here. X cubed. X cubed looks something like that, right? So what would you say? Is this continuous or not continuous? Let me open up the chat box in case people are going to answer through there.
Continuous?
Yep, that would be continuous. X cubed is like that ballerina dancer. So it's going to go ahead and continue because there's no asymptotes, there's no holes, nothing like that. Let me go ahead and pick at your brain a little bit more. What if it was x squared was my function? What if it was x squared? Oops. What if it was x squared or something like that? Would it still be continuous? Sure it will, right?
Yes.
Yeah, and if it's negative or positive, no matter what, it will still be continuous. So the first one are like these. These are super easy. You just think about the parent function. If it's x to some power, it's a polynomial. So we can go ahead and see how it is continuous. If not, you just think about the parent function dance. So this one is continuous. Yes, continuous. So I'm not even going to check the conditions because I already know that they are. Let's go to the next one. These right here, guys, these are a little bit more trickier. So I'll give you a couple seconds to write that out. These you do have to check the conditions. So let me go ahead and write them. F of c is defined. The limit as x approaches c exists, right? And the limit as x approaches c is equal to f of c. So that's what we're going to do. So is it continuous as at x equals 2? So that's what the question we want to know. So let's go ahead and do this. The first one says, is f of c defined? Well, let's think about it. Which one of these includes 2? 2 is located in which one? This is x. Yeah, because it has a little equal sign, right? This right here, x is less than 2. If I do my number line, this is 2. If it is less than 2, this is my left. This is my right. So 2 is only included on this one right here, because it has that little bar right here. So I'm going to substitute it into here. So at x equals 2, I got 2 squared minus 1. That is 1 minus 1, which gives me, I'm sorry, what did I just do? Whoa. 2 squared is 4 minus 1. There you go, 3. So the right-hand side said it was 3. So f is defined. Yep, it gave me a number. Now, does the limit exist? How do I check if limits exist? What do I need to do to the left and the right? I need to check, right? I need to check, is the left equal to the right in order for the limit to exist? Limit exists, question mark? Well, let's find out. On the left-hand side, if I substitute 2 on the left, if I substitute 2, I got 2 minus 1 equals 1. And on the right, I got x squared minus 1. And I substitute x equals 2, I got 4 minus 1 equals 3. So does my left equal my right?
No.
So therefore, my limit does not exist, So is this true? Does my limit equal my f of c? Well, if one of this fails, guys, it all fails, so no. because my limit does not exist and my f of c is 3. So this is not continuous. Not continuous because it does not exist. So this has a jump because at some point it was 3. At some point it was 3 and at another point it did not exist. So that's how I know this piecewise function jump, because it was probably here and then it was probably here on my function. Does that make sense? So it's not continuous. That is our answer, guys. Not continuous because it has a jump at x equals 2. Any questions, guys? Sorry, I'm trying to fix this here. Let's go ahead and try one more. So I'll give you a couple of seconds to write this out. And we are checking the same exact thing. Does f of c, is it defined? Is the limit of x approaches c, does it exist? And last but not least, does the limit equal the same as f of c? So when x equals 1. So okay, I'll let you guys go ahead and try it first. I want to find f of c. Consider that this right here, when x is less than 1, this is my left. And when x is greater than 1, this is my right. So which one am I going to use for this? Am I going to use my left or am I going to use my right to find f of c, to find f of 1? Which one actually includes 1? The left or the right? This will be on the right because it has that little equal sign, which I abandoned. So it's going to be x squared minus 4x plus 3. And I'm going to substitute x equals 1, right? Because that's the where both of them are equaling to. So it's going to be 1 squared minus 4 times 1 plus 3. So it's 1 minus 4 plus 3. That gives me what? 0. So f of c is 0. And the next one says that I'm going to check the limit. Does the limit exist? Question mark. Well, for that we check, does the left equal the right? If you forgot how to do this, guys, this is from last week's notes. So we're gonna check 2x minus 2. Does it equal to x squared minus 4x plus 3? When x equals 1. So what we have to do is substitute. So 2 minus x, which is x is equal to 1 minus 2. So it's 2 minus 2 equals 0. And on the right hand side, we already did it. On here, this was the right. It's also 0. So 0 equals 0. So the limit exists. Yes. Limit as x approaches c is equal to 0. So my limit is 0 and my function is 0. Whoa, what does that tell us? It is continuous. Continuous. Whoa, can't spell, guys. Continuous. It is continuous at x equals 1. Any questions, guys? Hopefully it's not that bad, guys. Can I continue? I believe I only have like about one more. All right, go ahead and try this one, guys. Find out if it's continuous or not. And I'll go ahead and write the restrictions right here. Does f of c, is it defined? Does the limit as x approaches c exist? And is the limit as x approaches c equal to f of c? So find out if these all check out. Okay, so I'll give you about what, 2 minutes? Sounds good. Go ahead and try this one. Sorry about that. So go ahead and try this one. Find out, does f of c is defined? Is it defined? Is the limit, sorry, is the limit as x approaches c exist? And does the limit as x approaches c equal to f of c? Okay. So we were able to see that at 1, it's only defined by a right-hand side. So I went ahead and wrote that here. And I substituted x equals 1. So it's now 2 times 1 plus 3. Quick math tells me that is 5 on the right-hand side. So f of c is defined. Yes, it is. It gave me a 5. The limit as x approaches c, is it defined? Well, I need to check my left. Now, this looks funny to me, but it's not that bad. This is saying all the numbers, no matter what x is, to the left of 1 is 5, no matter what you do. So it's going to be 5 no matter what, because it's on the left. Is equal to the right. Well, on the right-hand side, we just did that. That is 5. Lucky me, it is equal to 5. So my limit, it does exist. It's equal to 5. So therefore, 5, whoopsie daisy, 5 is equal to 5. So yes, it is continuous at what, x equals 5, sorry. Any questions, guys? Other than that, that's all I have for you guys. This homework will be due on Friday because I don't want you guys to stress about anything else. So this is all I have for you guys.